Welcome to the Story of Us. I'm your host, Madison Reed, and today we're diving into one of the most extraordinary and defining threads of our shared human experience: the evolution of language. But this isn't just about grammar rules or ancient scripts. This is about the sounds, symbols, and stories that built civilizations, connected minds, and quite literally shaped what it means to be human. Imagine this. You're standing inside a prehistoric cave, tens of thousands of years ago. On the wall, handprints and painted animals dance in the flickering light of a fire. No written words, no spoken sentences recorded. Yet somehow, a message is being sent. Across generations. That impulse? That need to share, to express, to connect? That's where our story begins. Today, we'll trace the journey from primal utterances to digital code, explore how language evolved, not just to communicate, but to cooperate, to imagine, and to create culture. And perhaps most fascinating of all, we'll look at how the words we use might not just reflect our thoughts, but actually shape them. This is more than a history of language. It's a story about how we became us. Let's start with a question that has puzzled scientists for generations. When did we become, well, us? Not just upright apes with bigger brains, but beings capable of sharing intricate thoughts, telling stories, and building civilizations through the power of words? The answer isn't what you might expect. There was no magical moment, no evolutionary light switch that suddenly clicked on. Instead, language emerged through what scientists call a gradual transition, a beautiful dance between our evolving bodies, that's the hardware, and our developing minds and cultures, the software. Picture this. It's 70,000 years ago, and something extraordinary is happening. Our ancestors are preparing for the Great Migration out of Africa, the exodus that would eventually populate the entire globe. Here's the remarkable thing. Every single population that spread from that migration possessed sophisticated languages, not basic communication, but full, complex linguistic systems. But wait, it gets even more fascinating. The Neanderthals and Denisovans, our ancient cousins, also had complex languages. This tells us something profound. Either language emerged before these groups split over 600,000 years ago, or the physical machinery for language was already in place, waiting to bloom independently in each group. Think about that timeline for a moment. While our species, Homo sapiens, only appeared around 300,000 years ago, the foundations for language may have been laid much earlier. Our brains had been growing for over 2 million years, expanding from the time we first split from other great apes 6 to 7 million years ago. Those smaller, earlier brains simply lacked the complexity needed for fully functional speech and language. By 100,000 years ago, our ancestors had bodies indistinguishable from ours. But the real evidence of advanced cognitive abilities, and by extension, sophisticated language, explodes onto the scene around 40,000 years ago. That's when our ancestors began creating art, marking a quantum leap in symbolic thinking. Now, let me transport you to a cave. Not just any cave, but one of the most significant archaeological sites on Earth. We're on the Indonesian island of Sulawesi, stepping 8 paces from a cave entrance where our ancestors lived for thousands of years. On the wall before us stretches a mural measuring 1.5 meters wide. But this isn't just any painting. It's a window into the minds of people who lived 39,000 years ago. Using red ochre blown through thin tubes, they created stencils of their own hands, leaving ghostly outlines that seem to reach across millennia to touch us. Alongside these handprints are drawings of a fat pig and a peculiar creature called a babirusa, a pig deer unique to this region. Simultaneously, thousands of miles away in Europe, similar artistic revolutions were unfolding. In southern France, artists were creating some of the most beautiful and skillful paintings ever discovered. The famous Lascaux Caves near Montignac became a Pleistocene art gallery around 17,000 years ago, containing over 6,000 depictions of hunts, horses, bison, felines, and the now extinct colossal elk Megaloceros giganteus. These artists weren't working with simple tools. They used charcoal and hematite, suspending pigments in animal fats and clay to create paintings of phenomenal quality. They understood light, shadow, and perspective in ways that would make modern artists envious. But perhaps the most intriguing discovery comes from the Chauvet-Pont d'Arc cave, home to the oldest wall art dating back 37,000 years. Here, artists portrayed various beasts in dynamic hunting scenes: cave lions, hyenas, bears, and panthers, all rendered with stunning realism and movement. Now, prepare yourself for one of the most mind-bending artifacts ever discovered. In the hills between Nuremberg and Munich, archaeologists uncovered something that would challenge everything we thought we knew about ancient human cognition. Meet the Löwenmensch, the Lion Man of Hohenstein-Stadel. Carved from woolly mammoth ivory approximately 40,000 years ago, this figure is unlike anything found in nature. It's a chimera, part human, part lion, a creature born entirely from imagination. Think about what this means. Our ancestors weren't just copying what they saw around them. They were combining concepts, creating something that never existed, dreaming up hybrid beings that lived only in their minds. This is abstract thinking at its finest, the same cognitive ability that underlies complex language. And here's where it gets really interesting. Chimeras didn't disappear with our ancient ancestors. They've been a constant thread throughout human cultures. Mermaids swimming through our maritime myths, fauns dancing through Greek forests, centaurs galloping across ancient battlefields, the Indian monkey god Hanuman, the Japanese snake woman Nur-Ana, Bavaria's whimsical Wolpertinger, with its duck, squirrel, and rabbit parts, complete with antlers and vampire fangs. Fast forward to today, and we're still creating chimeras, but now we do it with genetic engineering. We have cats that glow green thanks to crystal jellyfish genes, and goats that produce spider silk in their milk, courtesy of golden orb weaver spider DNA. Our ancient fascination with hybrid creatures has evolved into the ultimate manifestation of our creativity. This brings us to a crucial question. What makes human communication so fundamentally different from animal signaling? Sure, animals can communicate. A chimpanzee can express fear, hunger, or affection. Your dog knows exactly how to tell you it wants a walk. Parrots can repeat, "Polly wants a cracker," with perfect clarity. But here's the thing, they're stuck at that level. A chimp might identify a picture of an orange when prompted, but it cannot discuss the abstract concept of orangeness or debate whether orange is more similar to red or yellow. It cannot tell you about oranges it ate last week or plan to eat tomorrow. It's trapped in the immediate present, limited to simple expressions, commands, warnings, and recognitions. In the 1970s, scientists conducted fascinating experiments teaching chimpanzees sign language, hoping to discover whether these intelligent primates could grasp grammar and syntax. Linguist Noam Chomsky was skeptical, remarking that an ape developing true language ability was about as likely as finding an island somewhere with a species of flightless birds waiting for human beings to teach them to fly. Decades later, Chomsky's skepticism appears validated. Despite intensive training, no animal has demonstrated the capacity for true language, for combining abstract concepts into infinite possibilities, for discussing things that don't exist, or for building complex arguments about hypothetical scenarios. Here's something remarkable. Just as birds don't need flight school to soar, humans don't need language school to talk. Language emerges naturally in human societies, and exclusively in human societies. Think about it. Before the Neolithic Revolution, the number of languages likely equaled the number of tribes. Pre-colonial Australia provides stunning evidence of this. Before British colonization in the late 18th century, approximately 500 indigenous tribes existed, each averaging 500 members, and each speaking its own distinct language. As linguist Steven Pinker observed, "No mute tribe has ever been discovered, and there is no record that a region has served as a cradle of language from which it spread to previously languageless groups." This tells us something profound. Language is as fundamental to being human as walking upright or having vision. It's supported by genes that have been in our chromosomes so long, they've even been found in Neanderthal DNA. Why did language evolve? Survival. Our ancestors needed intricate cooperative behavior to survive in the wild. Simple pointing and grunting, as any parent of teenagers can confirm, can only achieve so much. Language became a biological adaptation, as essential to our species as opposable thumbs or binocular vision. But here's where the story takes an even more dramatic turn. While spoken language is natural and universal among humans, written language had to be invented, and it represents one of humanity's greatest technological leaps. Speaking allows communication within a group of people in the same place at the same time. Writing, however, enables something magical: the exchange of ideas across vast distances and time periods. It allowed knowledge to accumulate, building layer upon layer across generations. Long before the telephone or internet revolutionized communication, writing was our first groundbreaking communications technology. The scale of this invention becomes clear when you consider that while over 3,000 languages are currently spoken worldwide, only about 100 have been transcribed into written form. Throughout human history, writing systems appear to have been independently invented only a handful of times. The earliest known writing predates 3000 BC, originating in Sumer in southern Mesopotamia. Beyond this, we have clear evidence of only one other independent invention: in Mexico before 900 BC, Egyptian, circa 3000 BC, and Chinese, circa 1500 BC. Writing systems may also have emerged independently, but the evidence isn't definitive. Let me share a personal story that illuminates just how challenging inventing writing truly is. The author of our source material tells us about his childhood experience as a Cub Scout, when their pack leader challenged the group to invent their own writing system. While other kids made minor tweaks to the English alphabet, perhaps turning letters backwards or adding decorative flourishes, this young inventor created something completely different. When Mr. Peters, the pack leader, saw the unique system, he paused with grudging admiration before muttering, "You did a good job," hesitating over the word good, as if it cost him something to admit it. But then came the crushing question: do you attend Sunday school? Is this influenced by the Hebrew alphabet? The honest answer was yes. It was a variation of Hebrew. Though nothing to be ashamed of, it felt devastating at the time. This story reveals something crucial. Even as children with existing knowledge of how to break spoken language into basic sounds and map them onto letters, creating truly original writing systems is extraordinarily difficult. We already understood concepts like the and esh, being distinct sounds, could differentiate subtle differences between p and b, advantages the original inventors of writing never had. The development of alphabetic writing began when scribes started transcribing a new language, one belonging to the Semitic family, which includes modern Arabic, Amharic, and Hebrew. These scribes had a unique opportunity. They could discard archaic rules and adopt a systematic approach, ultimately revolutionizing written communication. The morphology of Semitic languages proved perfect for alphabetic innovation. These languages emphasize consonants, with word roots composed of fixed consonant frameworks and vowels that change around them. In Hebrew, for example, the root gdl, meaning big, can become gadol, big, masculine, gdola, big, feminine, gidel, to raise, gadal, to grow, and higdil, to enlarge. The creators of Proto-Sinaitic script realized they only needed to represent about 24 consonant shapes. Readers could understand the message by recognizing this consonant framework, a revolutionary simplification. But how did they choose shapes for these consonants? Through an ingenious mnemonic system called the acrophonic principle, using the sound at one end. Each shape represented a word beginning with that consonant. The consonant B was symbolized by a house outline, called Beth, in Semitic languages, which became beta in Greek. The glottal stop leading the word aleph, ox, was depicted by an ox head, eventually evolving into our letter A. Turn a capital A upside down, and you can still see the stylized ox head and horns. Our modern Roman alphabet is filled with these ancient drawings, now simplified beyond easy recognition. An M symbolizes waves, mem or mayuma. An N represents a snake, nahashu. An L is a lambd. A K signifies a hand with outstretched fingers, keaf. An R denotes a head, rays. This transformation process mirrors the work of neurophysiologist Keiji Tanaka, who simplified shapes until he found the minimal forms that still activated visual neurons in monkeys. Writing evolved similarly, progressing from realistic ox head depictions in Lascaux cave paintings to streamlined Semitic forms, then to the alphabetic characters developed by Phoenicians and Greeks. Through cultural evolution spanning countless generations, various forms were distilled into a compact inventory of basic letter shapes that optimally engage neurons in our inferior temporal cortex. Although variations exist across regions, they all stem from fundamental features in nature that our visual system processes most efficiently. Here's a fascinating parallel. New technologies often find applications far removed from their inventors' original intentions. When Thomas Edison invented sound recording, he didn't envision its use in music. He imagined it primarily for capturing dying people's final words or for office dictation. Similarly, writing initially served mundane administrative needs, keeping records and lists, functioning like ancient spreadsheets. The revolutionary potential for literature, philosophy, and preserving human knowledge came later. The alphabet made literacy accessible. Learning to read and write no longer demanded years of specialized training. Anyone sufficiently motivated could master 20-odd letters. Consequently, alphabetic writing spread rapidly across the globe. In ancient Ugarit on the Syrian coast, the alphabetic principle was adapted for clay tablet writing. 13th century BC excavations revealed inscriptions using a cuneiform alphabet derived from the Semitic system. This system ultimately led to all the world's alphabets, first evolving into Phoenician, then branching into Greek, Cyrillic, Latin, and likely all Indian scripts. Hebrew script has remained largely unchanged, while Aramaic became the foundation for modern Arabic, now read by approximately 200 million people. Now, let's explore one of the most surprising discoveries in modern linguistics: how language might actually change the way we perceive the world around us. Color perception provides a perfect example of language functioning as a lens, not a physical lens altering photons entering the eye, but one that profoundly influences our sensory experience within the brain. Your brain engages in constant, elaborate normalization processes, continually adjusting retinal signals to create an enduring illusion of stable colors despite changing lighting conditions. This complex mechanism involves manipulating and modulating signals from the retina, amplifying certain differences while minimizing others. The precise manner in which the brain executes these adjustments remains mysterious, but prior memories and stored impressions clearly play significant roles. Remarkably, experiments have shown that a gray image of a banana can appear slightly yellow because the brain, recalling banana's typical yellow hue, adjusts perception to match this expectation. Language appears to influence color perception at this level of normalization and compensation. The brain depends on its repository of past experiences and ingrained distinctions to evaluate color similarities. While the exact interplay between linguistic and visual circuits remains unknown, current evidence strongly suggests language has tangible impacts on our visual sensations. This brings us to one of science's most intriguing journeys, one that began in 1858 when scholar Gladstone noticed something odd about Homer's descriptions in the Iliad and Odyssey. The ancient Greek poet seemed to use very limited color vocabulary, describing the sea as wine dark and using the same word for different colors that seemed obviously distinct to modern readers. Gladstone initially proposed that ancient Greeks had underdeveloped color perception, that their eyes literally couldn't distinguish colors as well as ours. This hypothesis launched a 150-year scientific journey that would revolutionize our understanding of the relationship between language and perception. The breakthrough came in 1984 with Kay and Kempton's experiment. They discovered that English speakers perceived shades on the green-blue spectrum as more distinct from one another than speakers of languages with different color categories. More recent research has demonstrated that people react differently to colors based on their linguistic labels, perceiving them as more distinct than they may objectively be. The conclusion would have seemed impossible until recently. Speakers of different languages may actually perceive colors in slightly varying ways. After 150 years of investigation, science has come full circle to something approaching Gladstone's original hypothesis, but with a crucial reversal of causation. It is indeed feasible that ancient Greeks perceived colors differently from us. However, our understanding has fundamentally shifted. Gladstone believed Homer's limited color vocabulary resulted from inherent differences in color perception. Current perspectives suggest the opposite. Variations in color vocabulary across languages can actually shape color perception. Gladstone attributed Homer's limited color terms to an underdeveloped visual system, but we now know the anatomical structure of the eye has remained unchanged for millennia. Instead, cognitive training provided by more nuanced color vocabulary may enhance our ability to discern fine color distinctions. This represents a broader transformation in how we explain cognitive differences. In the 19th century, it was widely believed that hereditary mental faculties varied greatly among races, with these biological disparities supposedly underlying different achievement levels. One of the 20th century's major intellectual triumphs was recognizing the essential cognitive unity of humankind. We no longer primarily attribute mental characteristic differences among ethnic groups to genetic factors. In the 21st century, there's growing appreciation for cognitive differences shaped by cultural practices, particularly through language. The explanation has evolved from anatomical differences to cultural influences. That's our deep dive into the breathtaking evolution of language, from symbolic cave art to the alphabets that shape our modern lives, from primal grunts to poetry, from shared memory to future-thinking machines. But truthfully, we've only scratched the surface of this endlessly unfolding story. Language isn't just something we use, it's something that uses us, shaping how we think, feel, and connect. And as we move deeper into the digital age, where emojis sit beside ancient glyphs and AI begins to speak in our own voices, the story of language is entering a bold, new chapter. Curious about what comes next? Head over to the Skoob app and dive into the full podcast episode on the evolution of language. Download the app now from the App Store or Play Store and keep following the thread of our incredible human story. Thanks for joining me on The Story of Us. I'm your host, Madison Reed, and until next time, keep listening, keep wondering, and remember, every word you speak is part of the story we're still writing together.